right? First hop redundancy protocol. In this is just a title actually. This is not the protocol name. We have three protocols. One is HSRP, Hot Standby Routing Protocol. Hot Standby Route Redundancy Protocol. Virtual Route Redundancy Protocol. There is also one more but not popular, which is GLBP, Gateway Load Balancing Protocol. Now in CCNA, I'm going to do this one. I'm going to explain this one in detail. In CCNP, you will see again all of it in detail again, including HSRP. Right, so what is this first hop redundancy protocol? What is it? First hop means what? For a computer, what did you say? What did you say? Okay, to a computer, default gateway is the first hop. You understand now? First hop. For a computer, if a computer wants to go, if your computer wants to send a traffic to internet, where will it send? It will send to the first router, first hop, which is nothing but gateway. Do you agree? Do you understand what is first hop now? Right. What if that first hop goes down? You cannot go online. We cannot go online. So, for example, I have computer 10.0.0.1, 10.0.0.2, and these two are connected to a switch, and there is a router. We have wire, connecting to the router. Let's say this as edge router. So the address that you have here, 10.0.0.3, that becomes the first hop address. In another word, gateway address. That's the first hop for the router, for the PCs. 10.0.0.3. 10.0.0.3. Yeah, this is default gateway. You understood what I'm saying? This is first hop. The gateway is the first hop. Now, what is the title? First hop redundancy protocol. That's the title. And what protocol we are going to learn in that? Hot standby route redundancy protocol. Hot standby router protocol, or routing protocol, anything you can say. What does that mean? It means that if this fails, you're going to have another router to take care. And where is that in the diagram? I'm going to draw. I'll call this as edge 1, this is edge 2. Now, 10.0.0.4, we have two edge device. we have two edge routers. Yep, this connects to where? To the internet. So our aim in adding another router is, if this router fails, the traffic that was going this way now will go this way. That's the idea of introducing another router. But will this work? No. It won't work unless you go for a protocol like HSRP. Why do I need protocol? Why it won't work? It won't work. Why? It is because this address need to be changed to this address. Only then the traffic that was going this way can go this way. You understand the practical difficulty? Not only that, one thing we already saw, going to every computer and changing this address by putting number 4 here is not practically possible. Even if you have many employees to do that, that is going to take a really long time. Take on megaphone and say, hello, hello, mic testing, listen to me. All change your gateway. Are you listening? You. Change the 10.0.0.3 into 10.0.0.4. Then one lady will say, what did you say? Change the IP address. No, not IP address. Don't change. Change the gateway. What is gateway? Change the third address. That is gateway. Into 10.0.0.4. All the reading 0. It's not possible. Yeah? Going to every computer and changing the gateway address is not possible. This should be answered. If you want redundancy, this need to be answered. This need to be solved. Secondly, these PCs were having this router's address as the gateway's MAC address. Now you need to switch to BBB. Even the MAC address also need to be changed in the ARP table. In the ARP table, the gateway address is changed, so MAC address also need to be changed. You understand the problem? Which is not possible in the real world. Maybe in your home it will work. You go to every computer and change the gateway address. Before it was going via 10.0.0.3. Now that router has gone bad, you have another router at home connecting to the internet. You can go to every PC and change that PC's gateway address to 4. And then it will start a ARP request and then learn the MAC address to BBB and it will go. But there is going to be really a long time for this to happen. So these two things need to be answered. Only then this redundancy will work. Yeah, these two things have to be answered. if the E1 goes down, E2 you want it to be a backup for which these things need to be answered. That is why we need this HSRP. What this HSRP can do for us? It creates a floating router. So where is the floating router? I have here. It's not a real router. It is not a real router. This has got an IP address and a MAC address. And the IP address you assign. And the MAC address HSRP will assign. HSRP will assign. HSRP will assign. I repeat. MAC address we don't assign. But IP address we will tell the router, both the router, that 10.0.0.10 is the HSRP address. And we will not give 3 or 4 as gateway. We will give that floating IP address as a gateway. Now, what happens when you enable HSRP with an IP address? One of this router becomes active. In another word, here we call it as master standby. One of the router becomes the active router. Other becomes the standby. Active router will take ownership of this floating router. What does that mean? This router's IP is what? 10.0.0.10. So active router will say, I am going to respond. Yeah, it's me. I am going to respond to 10.0.0.10. I am active. I am 10.0.0.10. Okay. Now, when this guy send an ARP request, who is 10.0.0.10, this guy is going to send a floating MAC address. Let's say the MAC address is CCC. That will be provided by HSRP actually. It will look like this actually. It won't be CCC, it will be 07 AC like that. But you will definitely see 07 AC in the MAC address, in the middle of the MAC address. So E1 is saying, I own this 10.0.0.10. So now all the traffic will be going this way. And the MAC address is what? 07 AC. 07 AC. Whose MAC address is this? It's the MAC address of the floating router. Yeah, it's the MAC address of floating router. So you see, the floating router is now with E1. So the MAC address traffic to 07 AC will go through E1 because E1 is owning that floating. The active device will take the ownership of the floating router. See, it won't float and all. Just for your understanding, we say that word. Why we call it as floating router? If in case this one goes down, this becomes active. Now this router will respond to that MAC address 07AC. This router is owning the 10.00.10. So now all traffic will go this way. You see how easily the problem is solved. Wherever the active router is, that floating router is going to be. Did you understand, Pavitra? So the floating router moves from E1 to E2 when E1 failed. Yeah. So the MAC address and the IP address is not changed. It's the same IP address 10.00.10. So you don't need to go to every computer changing the gateway, nor the MAC address. Fine. Then the question is, how E2 knows E1 is dead? How E2 knows E1 is gone? See, only when active device goes down, standby can become active. For that, E2 to make that standby to active, E2 should make sure E1 is dead. How is that possible? You know, these routers, no? They keep sending hello packets. Hello, 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 every 3 seconds. They keep sending, both of them sends hello packet. Now, a hello goes, hello, that's all. No hello is coming. Clock is ticking. 10 seconds over. That's all. I am active. I waited 10 seconds. No hello came, which means I have to take the ownership of the floating IP and MAC address. Packets are moving this way. So you don't change neither IP address nor MAC address on the inside computers. It happens automatically. From one router to the other, packet gets switched because the IP address and the MAC address is same. Only the hardware is different, but that doesn't matter. We have a floating IP and floating MAC address provided by HSRP. See, this is the work what HSRP does. It provides a floating IP address and MAC address so that it can float between active and when the active goes down to the standby and make it as active. All right. If you don't have any question, we will go to practical. Are you ready for practical? I'm giving gateway address is 10.00.10. This is not an address on any of the router. You see, on this router I'm going to give 10.002, 10.003. But the gateway is 10.00.10. Why? Because that's going to be the HSRP floating address, correct? So we have configured IP, mask and the gateway. Now let us go to this router here. Okay, before that here I want to have 20.001/8, 20.002. Right. See, if packet comes to this internet router without NATing, it will come with 10001. Internet router don't know where is 10001. So what I do is, just for the sake of routing, I'll write a default route so that the replies may come. Done. I've just put 10 G000 outbound. Okay, so we have written as default route for the return traffic. We are going to now test. Sorry, we have not finished the gateway 1 and gateway 2. Let's go to gateway 1 and gateway 2. This is gateway 1. Ten 002, and then interface G001, 20001. Done. On G2 also, I have to configure those two IP addresses. Interface G001, IP address is 2002, interface G000, IP address is 10003. Do you follow?
Yes.
Okay. So right now, if I try pinging from here, the ping won't go. The reason is the gateway that we have put nowhere exists. This gateway doesn't exist anywhere. So if gateway is not reachable, then you cannot ping 20. You cannot ping anyone in 20. Now let us go and configure HSRP. Very easy. I'm going to the first router and say, go under the interface actually, and say which interface? The switch facing, the down LAN facing interface. IP, sorry, not IP. Standby, that's the command. Don't expect command to begin with HSRP. It is standby. Standby, give any number. 1, and it's the same number, you should do it on the other router. 1, I use 1, so I'll use 1 there. IP, what IP? The floating IP? 10.00.10. That's all actually. So easy. HSRP is enabled. Show standby. You can see here it is in a speak state. Soon it will become active. You see, I told you, 07 AC, the MAC address 07 AC. It's here. And this is the Oh, just only one command. Standby. You need to give a ID, and that ID should be same on the other router. Same ID. And the entire line, it should be same on the other router. But I have not still configured the other router. We have just only one router now configured, and that router has become active already. And this is the floating IP address we gave, and this is the floating MAC address that HSRP gives. It will have 07 AC, I told you. And what is the 01? This one is the one which I configured. I gave one now while configuring. That one only, this number 1 only you see in the MAC address on here. If I would have given 5 there, you would have seen 5 here. Last number of the MAC address. You understand? Now you can see here the standby router is unknown because we have not configured router B. Now let's go to router B and configure interface G000 standby 1 IP same 10.00.10. Now this will go to standby. That is active now. So this will go to standby now. Show standby. It is in speak mode. Soon it will go to standby. See? Now let us go to router A and check. See, router A says there is one standby router whose IP address is 10.0.0.3. Is that right? That's right. So they already discovered each other. They are talking each other. Now let us try pinging from here. This gateway will ping because you already have HSRP enabled. As a result, you will be able to ping 20.0.0.3, which is internet. You see, you are able to ping 20.0.0.3. Now let us cut this wire. Are you ready? Do you understand what I am saying? I am going to cut this wire, or I can shut down the router. I'll do one thing. I'll save the configuration. I'll go here and I'll off the router. I off the router. Now let us go to this PC. Now let us go to this PC and try pinging. It will ping in 10 seconds. It will ping because it will take 10 seconds for the other router to become active. Meanwhile, I'll go to gateway 2 and check whether it has become active. Yeah, it says I have become active. It says it has already become active. Now this is active. Standby is unknown because the other router is off. This is active, which means I should ping now. See, the reason why I'm not pinging is not this gateway or HSRP. It is this guy's ARP table. This guy has got ARP table to this MAC address, not to 20.0.0.2. That is the problem. That is the problem. Usually in the real world we don't have like this. We'll have one connection from here, one network, this is another network, so that problem will not be there. But this design, I just to save some time I did. Now if I clear ARP, it will ping clear ARP, show ARP. We have 20003. Want to clear ARP again. Why it is having this? This is simulator's problem. Even okay, now only it is clear. Now if you ping, it will definitely ping. So this switchover has happened. From there it switched to this one. It will ping now. See, this is amber, switch is still in a learning. Okay, now it is green. It will ping now. Try again. See, it's going via the other router. Now let us bring this router back. Now this will go to standby. So we no need to change the IP address or a MAC address on this computer in our LAN. We are able to switch between one gateway to another gateway. That is why it is called as first hop redundancy protocol. In that HSRP we have seen. Right, it is in speak state. Soon it will become standby because the other one is already active. So this one will only become standby. And then no, it should not be active. Yeah, it's again going to speak state because the other guy says, how can you be? Okay, now you see it has gone to standby. Yeah, it has gone to standby and it says active is 10003. So still the ping is going to happen for you without any problem. All right.